Okay, our goal on this is to simplify the tangent of pi over 2 minus x using a sum or difference formula, one of these identities that's listed over on the right-hand side. So I think most of our first inclinations are just plug in, right? This is going to be our alpha, this is going to be our beta. Let's plug into that top formula and see what it looks like. So on the right-hand side, what that would be tangent of pi over 2. That's replacing our alpha minus tangent of beta. So beta is going to go with x in that spot over 1 plus tangent of pi over 2 times tangent of x. But let's see what happens when we do this, because we can go ahead and try to simplify down tangent of pi over 2 and see what does that work out to be. Well, tangent of pi over 2, we have come up here and here. In both those cases, we can't actually evaluate tangent of pi over 2, so we would say that it is undefined. However, the answer to this is not undefined, surprisingly enough. Instead, what we want to do in this case is we want to rewrite our difference, that tangent. We can replace tangent with sine over cosine, right, using a quotient identity. So as we do that, we're going to get sine of pi over 2 minus x over cosine of pi over 2 minus x. Well, we have different formulas for sine and cosine. The difference formulas over on the right-hand side, looking right here and right here. So let's think about plugging in using those formulas. Again, in both these cases, alpha is going to go as pi over 2 and beta is going to go as x. So this is going to look like, on the right-hand side for sine, we can replace it with sine of pi over 2 going in for alpha, multiplied by cosine of beta, which is in our case x, minus cosine of alpha, which is pi over 2 in our case, multiplied by sine of beta, which in our case is replaced with x. And then for our denominator, let's do the same idea, right? It's going to be cosine pi over 2 multiplied by cosine of x plus sine of pi over 2 multiplied by sine of x. And as we think about simplifying these down, I think we'll work out pretty nicely as we get going on this that we can evaluate sine of pi over 2 is 1 multiplied by cosine of x minus, well, cosine of pi over 2 is 0 multiplied by sine of x, all over, again, cosine of pi over 2 is 0 multiplied by cosine of x, plus sine of pi over 2, which I should get rid of, my apologies. We're going to replace sine of pi over 2, if my marker will work, with 1 multiplied by sine of x. So in looking at this, wherever we have a 0 multiplied by something, like right here, that's going to go away, right? 0 times anything makes 0. 0 times cosine is going to make a 0 down here as well. So what are we going to be left with? Well, we're left with cosine of x times 1, which is cosine of x, over 1 times sine of x, which is sine of x. And then we can use one last identity to say, well, cosine over sine is the same thing as cotangent of x. And how we make that leap at the end there, going from cosine over sine of x, is cotangent. That's another quotient identity. All right, so hope this helps out in simplifying these down. Don't give up just because you can't evaluate tangent of pi over 2. We can get around that by rewriting our tangent as sine over cosine and evaluating into that. So I hope this helps out as you're working on solving these down, simplifying as much as possible. Good luck.